Today we'll discuss why choosing to work with PennEngineering for your AE fastening needs can help yield better designs. PennEdge is a suite of free services to help you get the information you need to make an informed decision. With PennEngineering, you have the opportunity to work directly with our applications engineers at your convenience. You may choose this via either the online chat, or you could schedule a virtual consultation with them. There are several reasons why customers choose self-clinching fasteners. One is certainly the strength of the threaded joint. These are stronger threads than you get had you tap the panel. It's faster operation. This leads to cost reduction, especially if you have high volume applications. If your product is formed in stamping press, we can work with you to install these fasteners at very high speeds right within the die. These are in-die capable fasteners. Also, versus welding, there's great design flexibility. Our fasteners, clinching fasteners, can be installed into dissimilar metals, whereas with welding, it's best if the materials are the same. Here, you can install stainless into aluminum. Dissimilar metals are not a problem for self-clinching. It's a very clean process as well. It's very environmentally friendly. A lot less energy is required to run a press than it is to weld something in, and there's no secondary action that's needed, like to clean a weld spatter that's going to be necessary with welding. So there's been many reasons that customers over the years have gravitated towards clinching and away from welding. There are obvious mechanical advantages of choosing self-clinching fasteners for design, and many of those are shown in the column on the left. But what's often overlooked is the fact that there's DFMA benefits of self-clinching fasteners. This is designed for manufacturing and assembly. This is the actual process of utilizing a part and getting it into the product. There's fewer parts to handle, there's going to be fewer assembly steps, there's less total assembly time, and this leads to what we call total installed cost. It is not the cost of a bag of 1,000 fasteners, as well as the actual cost to put those fasteners into the product, trust that they're going to work well, and have confidence that the end user, the ultimate customer, is pleased with the result. And so this total installed cost is a huge benefit as well by choosing self-clinching fasteners. You can trust our PEM Clean Lab for your ever-increasing technical cleanliness requirements. Now we will discuss the new PEM eConnect fasteners. The ability to efficiently move large amounts of power through a system is something that we know is going to be growing for years to come. The electrification we see in automobiles and other markets requires this. So we are proud to offer the eConnect pin, which is offering our customers an alternative to the current methods for which they try to move this power. The PEM eConnect pin is a true total installed cost benefit for the customer. On the left is a typical pin that's manually assembled with a loose washer, perhaps also a loose star washer, and a loose nut. All of this must be handled individually, and it's a much slower process. On the right is an example of a fastener that would be used on a PC board. Both of our solutions greatly speed up the installation process. They can be done automatically with a Hager press. And so ultimately the savings in throughput, increased throughput and cost savings in labor is what a customer will recognize by switching to our fasteners. The actual usage of our eConnect pin will be recognizable to our customers. All we're doing here is offering them an alternative method to either clinch it into their bus bar or to adhere it to their PC board. But the use of the mating sockets will be identical to what they're doing now, so there really won't be a big change to them other than the recognition of all that total installed cost savings that they can benefit by switching from those other fasteners to this style. In the past, we have quoted some of these as Y numbers. We can continue to do so, but we do anticipate that this product line, this eConnect, will become a product line this year. 2023 is this pin. Perhaps in early 2024 will be the mating socket, and there could be more parts added as customer requests continue to come to us. The next in the growing line of eConnect fasteners is the contact bushing. This part is designed to provide very strong mechanical and electrical connections in both aluminum and copper bus bars. The PEM eConnect system will greatly improve and streamline your bus bar assemblies. It will reduce cost. No longer will you need to send the bus bars out to a third party for tin or more expensive silver plating. You'll no longer need to clean the bus bars in order to remove oxidation. Oxidation is a big concern because that can increase the electrical resistance. By choosing the PEM eConnect system, you're going to reduce the electrical resistance in your bus bar assembly. As seen here, the electrical resistance is greatly reduced with the incorporation of the PEM eConnect system. This is because there's no longer the concern of oxidation with a metal-to-metal joint. Now we will discuss some applications for sheet metal. In this copper bus bar application, a large diameter clinch nut was designed that incorporated our locking feature known as ramp thread. This ensured a proper clamp load could be achieved and that there would be no joint loosening. In this application, a bus bar stud is clinched into the bottom side of the copper bus bar. An anti-rotation spacer was required and designed so that it could be clinched safely into the top side of the bus bar. For this battery chiller, the customer is testing a standard 304 stainless stud, but they're concerned about the 600-degree baking cycle that this must endure, so we've designed a version made out of A286 material, and they will also test that. This battery connector design needed a system solution. A special bushing was designed, but also the integration of our press into a robotic production line was required to achieve the necessary force distance control. This customer switched from a cast aluminum housing to a stamped metal version. A concealed head bushing was designed due to its water tightness, and a system solution was provided to install these parts during that stamping process. This is another example of where loose screws were previously designed into a product, but they did not like the risk associated with all those loose screws, 18 of them in this application. So they chose the SCB to become a captivated solution. The jacking style, the SCBJ, was chosen in this voltage sensor and was designed with a very large M8 size thread. Now we'll discuss some applications for cast materials. The increasing use of cast materials requires the development of alternative fasteners. In this application, blind fixing points are created by broaching these pins into precast bosses. This is a good example of how a casting can create these intricate shapes that would have taken a lot more effort to have done had this product been made out of a block of magnesium, a billet of magnesium. So creating casting, they can get these shapes. And when they wanted to create a nice strong metal thread, a thread stronger than the cast material itself, they decided to put in the KFE style nuts to get that strong internal metal thread. Another benefit of tack certs versus screws is that it is evident, it's tamper evident if a tack cert is attempted to be removed, whereas a screw could simply be unthreaded and then threaded back in and no one would be the wiser. So for some applications, automotive, safety related items, the knowledge of whether something was tampered with or not is very important. Another benefit here was the sheer savings in size. Previously, the screw head was 9 millimeters in diameter, and now they're using a tack cert that's just under 2 millimeters in diameter. So the footprint is smaller, there's a weight reduction, and this enabled the engineer to have more options in his design as to what he wanted to do with the rest of the PC board. Now we'll show 3 very high volume applications where the customer converted from loose screws to tack pins or tack certs. This is an application that started from one of those PEM edge teardowns. We noticed that this customer had over 100 screws, basically at the intersection of the different keys in the keyboard. And a screw is theoretically removable, but we found that these little M1.2 screws patch, that patch works very well. And about a third of the time, the screw broke, the screw stripped, it camped out. So the reality was they were using screws that were removable, but they couldn't remove all of them, and therefore they certainly couldn't remove them all and replace them all. So we presented them this idea of the tack pin, and they agreed that they had a failure rate of about a third as well in removal. So effectively, it was a permanent assembly. So we suggested the tack pin, and they, to this day, are still using it and have happily replaced over 11 billion at this point in time M1.2 screws. But again, it's not just the cost of the screw that they're saving. It's all those other costs, what we use the term total installed cost. For example, think about 11 billion screws. They had 11 billion tapped holes. So they had to purchase enough taps to tap 11 billion holes. I don't know how long a tap lasts, but that's a cost that someone had to purchase that they no longer needed to purchase. That's the sort of thing. They never had a failure due to cross-threading because they couldn't cross-thread a tack pin. But they had to have failures from cross-threading when they used screws previously. It's all those additional risks that are gone when they chose to switch to a tack pin. This application with very high cosmetic requirements, the customer was going to use screws until they realized they had absolutely no ability to fit a screw into the small confined space. So they came to us and asked, can we design a tack pin to do so? And we had never designed one this small before. It was a third smaller than anything we had ever designed. But we figured out a way to do it. And now in these buttons, there are 2 tack pins per button, 3 buttons per case, and you can see here, the back side of these 2 buttons, the heads of the 4 tack pins. And also, we have the knowledge with our Hager side of the company about the importance of proper installation as well. So this material is anodized aluminum. It comes in many different colors, but with anodization, you need to worry about proper installation, because if not, you could put that little crack in the anodized surface, sort of creating what's known as spider webbing. And so it wasn't just enough for us to come up with a fastener that would fit in this very, very tight space. It was to design one that we would know would be able to be installed with correct pressure to prevent that risk of cosmetic damage. So it had to be physically the right size to fit, but it also had to not cause them any cosmetic issues. And we're able to solve that with this application, and they've been using this for several years now. In this application, a magnesium laptop frame, the thread forming screws were replaced with taxers. One of the reasons the customer wanted to replace them was they knew with the thread forming screws they were only getting a thread strength as strong as that brittle magnesium was. Also, they knew that they could not expect to be able to remove all of the screws, that some would cross thread on the way in, some of the drivers were stripped. Ultimately, even though they were removable screws, the reality was they weren't all removable, and if one couldn't be, then the entire assembly couldn't be. So in this case, they chose the TK4 taxers and were able to replace every one of those screws, and therefore saved a lot of money in the assembly process. Now we'll share some applications for circuit boards. I start with this first application because it's a very good summary of what we call total installed cost. And that's not the cost of the fastener, but what it is the cost to get that fastener onto the board and then trust it. So the OEM had chosen a broaching fastener from a competitor, and they're fine with that. They didn't really know that there were other options. But the fabricator that they chose did know that PennEngineering supplied surface mount versions of those parts. So the fabricator went back to their customer, the OEM, and said, look, if you allow us to switch from broaching, which is fraught with risk, if you allow us to switch from broaching to PEM surface mount products, I could be more efficient, and then I can save money, and I can share some of that with you. So that's exactly what occurred, and that's what we talk about total installed cost. The PennEngineering Real Fast part sitting in a tape and rip package, as an individual part, it's more expensive, but that's not the way anyone should look at it. They need to look at it, what does it take to get that part onto the board, trust that it's not going to damage the board and cause scrap, trust that it's going to stay adhered to the board and do the job it's supposed to do. And so the fabricator knew that what would happen. They went back, petitioned the OEM, and the OEM agreed, and then they happily switched from broaching to the PEM Real Fast. The key takeaway for this application win is that the customer utilized our PEM Edge services to make samples and to test both mechanically and electrically this new design, which reduced from 3 components down to 1, which therefore also reduced their required assembly time. This customer originally considered to hand solder onto the board several components, but with such a high volume, they knew that would become costly. So they worked with PennEngineering, who designed a specially externally threaded surface mount standoff and a spinning clinch nut that would be installed into the cable. And this reduced their total pieces as well as the cost. We encourage you to use our free PEM Edge services. We'd be honored if you felt that we were part of your engineering department. With our global footprint, we are there to serve you throughout the world. We can work with you from just the beginning of the concept straight through to when it comes off the production line. This customer wanted to eliminate the concerns of having loose hardware and the assembly costs associated with it, but they had bad experience with welding in the past. They instead investigated using clinch hardware, and they've been pleased with the results. A special M8 stud and installation method were developed so that when the part was pressed into the copper panel, it maintained a certain amount of flatness as well as provided the 25 Newton meters of torque that was required. This vibrationally concerned application also illustrates how if the customer is already putting SMT products onto the board via the reflow process, offering them additional fasteners to do at the same time is a great cost savings for them. The rest of the board was already done in that process. So by offering them surface mount parts instead of loose hardware, they could easily incorporate it, and after their testing of their shock and vibe scenario, proved that they held on greater than they needed.
As is typical with assemblies, customers are often looking to reduce as much loose products as possible. Here, they chose several different styles and lengths of SMT standoffs, and they utilized the PennEdge service in order to quote multiple styles, as well as to test those styles and determine what are the right parts for their design. In this application, the combined efforts of both the applications teams in Danborough and Kunshan worked to satisfy the customer, both the OEM in North America and the fabricator in China.